Greetings class and welcome to our coastal lecture. The topic of oceanography wouldn't be complete unless we included the coasts. We've talked about some of the biology and ecosystem uh, um, phenomena that occur along the coasts. Um, and the coasts are extremely important because they are where the land and the ocean meet, and that's essentially one of the defining characteristics. Um, So the coastal areas don't just include where the land and water meet exactly, but also the zones before and on either side of them, both before and after. So but I would say that the overall defining feature, or the best definition for a coastal area, is that it's a temporary structure, and that's essentially what most of this lecture will be about. So first, the coastal zone, right? So right where the water meets the land is obviously coastal, but then we have these certain sections both before the ocean and after it that are considered coastal zones. And really, it's really anything where either the continent is affecting the ocean or the ocean is affecting the continent. So any of those areas before and after that affect each other, considered coastal. So does the tidal action affect the the, um, the continent here, or tidal action or wave action, and does what's happening on the continental section here affecting the ocean at all? But as I said, it's the most defining feature is it's all subject to change because of those interactions. So why do we call them temporary? Okay, why are coasts temporary and subject to change? Well, there are many mechanisms for the way that it changes, and some of them can be very, very long-term changes, such as tectonic activity. Right, so we talked about how plates move, how they interact, they push on each other, they spread away from each other. If this is going on near the coast, it will slowly, over geological timescales, kind of change the coast. Plates moving, they spread, they close, and they change the structure of the coastal the defining coast there. Something such as glacial formation or recession can change the coast. If a glacier was to form right on a coast, it's so heavy that it actually depresses the continent, the crust below it, and can change the coast there. And as it melts, it can also rise again and change the coastline again, and that's called isostatic adjustment. Another long-term uh, effect on coastal structure change is sea level change, right? So we all know about global warming and warming trends due to human activity and that kind of thing, but really global warming and cooling are both very natural things that happen whether humans were here or not. So you can see 20,000 years ago, before we were even affecting our atmosphere very much, sea level was quite a bit lower than it is now. And so the prediction about 18,000 years ago was that the coastlines were about 200 kilometers longer, or seaward, out to sea. So we look at a place that's really low lying, like Florida, we see how much more coast they had 20,000 years ago, when there was a lot more ice formation in the Arctic and Antarctic. That water gets sucked out of the ocean as it turns into ice and exposes a lot more coast. And of course, this shape of Florida is where we're at right now. That's our coastline now. And the predictions are that as ice melts in the Arctic and Antarctic, the ocean will be flooded back with the water that was taken away here, and flooded back in. And so sea level rising will make the coastline of some of these low-lying areas as much as 250 kilometers inward. And so that's good news if you're a shark, right? But just wait for ice caps to melt. Sooner or later, this will be ocean, and those guys will have them, yeah. Okay, so what about the more direct coastal changes, the short term impacts? And the biggest one of those is weather. Right, so we can have very strong storms that change the coast very rapidly, right? We can have harsh climates where we get a lot of freezing and thawing. When you have freeze thawing, the water gets into things, it freezes, it breaks it apart. You have thawing, the water runs off and it erodes it off. And these are major forces in shaping our coasts. The other ones are the waves and tides, as I mentioned before. Right? Wave action has a very powerful physical force, and especially if we're talking about a soft substrate, it can dig it out in a matter of short periods of time. The tides coming in and out do that as well on a slower scale, and it's also strong enough to actually erode over long periods of time to just carve out even solid rock. Okay, so when things are carved out and then deposited in other places, it's the carving out or the is a process we call erosion. And when that stuff is carved out, it has to be put someplace, and some of it's brought out to the ocean, but some of it's also deposited somewhere else along the coast or any of the coastal zones. And so erosion and deposition are probably the two primary modes for coastal change, and a lot of that's due to waves and tides and weather, remember. So erosional coasts. Erosional coasts are due to constant wave action and tidal action moving in and out, sometimes due and often actually due to strong weather atmospheric activity, right? And so as wave energy hits points of a coast, so points that project out, it takes a high energy erosion here. And as it hits places that are more secluded or inland like this, it takes a little bit lower energy, but both places are carving away or eroding away portions of this coast, so it's constantly changing, right? So when you have these inland areas, the energy kind of diverges, and so it's low impact. When you have these outcrops here, it's taking strong converging energy, so it erodes faster, and eventually what it's trying to do is reach equilibrium so that this is all level here. Right, and that's how we get things like headlands or peninsulas, and eventually we get bays carved out on a coast. But erosion on a rocky coast can do things like erode cracks into hard substrate, eventually carve them out into a sea cave as it keeps going and keeps going. Eventually, if it breaks through a hard rocky substrate like this, we have an arch so that it's finally eroded all the way through. And then when weather has eroded completely through here, we get a completely separate piece of coastal structure called like a stack. And then when that stack is finally eroded, we get what we call a stump. And this is what happens over a long period of time. This is kind of the succession of eroding of a rocky intertidal coast. So once you get out of this lecture, you'll watch the video. I think this is the link for it, but once you can watch this video that I have posted right after the lecture, and it'll show just how quickly coasts can erode, especially if you're in a harsh environment. Okay, so that stuff that erodes, all that rock and sand and all that material that erodes off of the coasts has to be put someplace, right? And so the wave action moves the eroded stuff somewhere else, and very often as the waves dissipate, it just drops all that material. And in something called a longshore current, can drop all this material and form another structure down and away from the erosion by deposition, so by dropping that sediment. This can happen on beaches, and a lot of large-scale features are formed where these depositional coasts, where this material accumulates, right? So coast erodes up here and then is driven by longshore current or wave action or tidal action and deposits. It can deposit into a tip here and form a bay and a sand pit. It could deposit in these long barrier islands like here and here. Which can form a lagoon behind it, which can form a bay and an inlet. And it can form all these long-term structures that eventually will either get more deposition and become permanent attachments of the coast, or will eventually be eroded itself. But what are some examples of these depositional coasts? So Sandy Hook if anybody's familiar with Sandy Hook in New Jersey, is actually a sand pit, just like we saw right here. And the Outer Banks in North Carolina, North and South Carolina, are actually barrier islands, just like this one. Right, so we think of these as permanent structures because we go and we vacation on them, or we go to the beaches and swim there, but they're constantly eroding or having stuff deposited on them. Okay, so we get erosion, and then we get deposition someplace. Usually, it's a very repetitive thing on a long-term basis. So we get erosion from certain places along a section of coast. We get deposition in other sections, and it's just continual. Erosion from here, deposition here, erosion from here, deposition here. So this whole thing, where we're getting the erosion and the deposition continually, we call a coastal cell. So this is one whole coastal cell because the stuff that's always eroding from here and here is always depositing here and here. So what else? Temporary coasts, why? Because they're also subject, another thing they're subject to is biological processes, right? We have things that grow and break up or form or change different parts of the coast. One of the major examples is a reef, right? The Great Barrier Reef off the coast of Australia is so gigantic that it actually makes up part of the coastal zone. You know, some of this stuff you can actually walk on, and it's just old, essentially reef. But the other thing that it does is it actually protects the coast. So as these things form, the wave action and weather and tides that go in and out of here are actually reduced, slow down the changing features of the coast because the biological processes have protected it. We also get things like mangroves and marsh swamps, where large-scale plants and trees and giant ecosystems, where the root systems in the trees, they both erode and protect the coasts. So the other big feature that I want to talk about in coastal morphology is the fact that we have the structures physically changing, but we're also talking about the area where the ocean meets the freshwater, where the freshwater and the ocean meet. And so we have mixing of fresh and salty water, and when we have that, we call it an estuary. There are a bunch of different types of estuaries that are classified by their origins. You can get a drowned river mouth. This one in particular used to be a couple of different rivers that used to be here, and as it eroded, it became a larger open drowned river mouth where the salt water could wash up here and you could mix. Chesapeake Bay is an example of that, between Delaware and New Jersey. You can get a fjord, and that's where a glacier traveled past this area of coast and carved it out and allowed a large area open and allows now salt water to mix into this fresh water. Fjord. If anybody doesn't know why Pinky's in here, you should go back and watch Pinky and the Brain episodes. Another type of estuary is a bar-built estuary. So if we go back to our depositional coasts, you can get these deposits, barrier islands or sand pits, and it traps water in here. And it would just be mostly fresh water, except wind goes through here and mixes it and drags in salt water and turns it into another type of estuary. The Outer Banks, as we said, is a barrier island, and the lagoon in here that's trapped is actually a bar-built estuary. And then you can get a tectonic estuary. We talked about how plate tectonics near the coast, opening and closing, can open up spots, and San Francisco Bay is actually an estuary caused by that, right? This opened up in here because it was two plates that were moving, and as it opened up, the salt water is allowed to wash in here and mix with and be a tectonic estuary, mix with the fresh water. Estuaries are also classified by their water flow and density. If you have fresh water that just floods out into the ocean, you get a salt wedge estuary where it layers in here. If you so you get strong stratification, you got fresh and then salt fresh than salt. But if you get a different kind of mixing, a well mixing, you get a gradient between fresh to salty, and so on and so forth. And these are the different estuary types. And all these characteristics add up to coasts that you guys should recognize, like the U.S. coasts.